Hi there, I'm Jack Horrick with Thwink.org. This is an introduction to the WorldChange simulation model. The model was created by adding a change-resistant subsystem to the World 3 model of the limits to growth. Let's begin with why we've been pursuing this line of research. This is the most stubborn curve in the world. If solutions were working, the curve would have stopped climbing long ago, but it hasn't. Today, it's about 50% overshoot, right here. This is strong proof that change resistance is high. The system is resisting change to being sustainable. This curve is why we believe that as long as change resistance is high, the sustainability problem is insolvable. Therefore, overcoming change resistance is the crux of the problem. We know what needs to be done, but we're not doing it. We lack political will. We delay deciding to solve critical problems like climate change and deforestation. That's change resistance. It needs to be analyzed and modeled, just like we've done for the technical side of the problem with models like World 3, C-Roads, and Threshold 21. To get the best results, change resistance needs to be added to integrated world models like these so the models are complete enough to analyze and solve the problem. To take the first step in this direction, Thwink.org has added a change-resistant subsystem to the World 3 model of the limits to growth. The subsystem looks like this. The change-resistant subsystem is a surprisingly simple model. It fits on one page. The main purpose of the model is to illustrate how change resistance can be analyzed and added to integrated global models. Here's the change resistance node. It measures resistance to solving common good problems like sustainability. We used root cause analysis to build the model. To find root causes, you keep asking why until you find a root cause. Our first why question is, why is change resistance so successful? This led to the first root cause. It's right here. The root cause appears to be high political deception effectiveness. Too many citizens are being fooled into supporting politicians working for special interests, like corporations and the rich, instead of the common good. Here's the high leverage point for resolving that root cause. Right now, deception is working because truth literacy is low. It needs to be raised from low to high. A high leverage point is a point on the system structure where solutions push to resolve the connected root cause. Over here is the low leverage point current solutions are pushing on. This is a more the truth strategy. It does absolutely nothing to resolve the root cause, which is way up here. This explains why popular solutions aren't working. Now for our second why question. Why is there so much change resistance? What's the source of all this resistance against solving the sustainability problem? This leads to the second root cause. To see that, we're going to have to scroll the model up a little. The second root cause is right up here. This root cause is central to analysis of the sustainability problem, so let's explain it. The human life form has a name. It's Homo sapiens. The corporate life form needs a name too. Let's call them corporatus profitus. These are large, for-profit corporations. The goal of Homo sapiens is the long-term optimization of the common good for those living and their descendants. That goal is right here on the model. Now there's another goal to consider. The goal of corporatus profitus, which is entirely different, is the short-term maximization of profits. That goal is in the model right here. There's a problem here because these two goals, Homo sapiens, corporatus profitus, are so mutually exclusive they cannot be achieved in the same system. One life form will win and become dominant. the other will lose and play some sort of subservient role. Another way to say this is the two goals are in poor alignment, which is what this node captures here. And that's the root cause. Mutually exclusive goals for the top two dominant life forms in the human system. There's a fundamental principle at work here. In a social system, over time, the goal of the dominant social agent becomes the goal of the system. Corporatus Profitus has the goal of short-term maximization of profits. If you follow the money, corporations largely control jobs, products, technology, and new culture, and enough of the news media and political elections to get their way. So corporations are the dominant social agent. Because they're dominant, their goal and the goal of the human system have become one and the same. So the implicit goal of the system is short-term maximization of profits, the goal of Corporatus Profitus. This leads to all kinds of short-term decisions and requires a maximization of economic growth. Doing that requires not solving long-term problems like sustainability, because that would hurt short-term profits. So is it any surprise the sustainability problem has so far been insolvable? This leads to an important conclusion. As long as the goal of Corporatus Profitus is short-term maximization of profits, the sustainability problem is insolvable due to the wrong implicit goal, which causes high change resistance. Notice this balancing loop in the model. Let's take a look at what Peter Senge has to say about balancing loops and implicit goals. Peter would take a look at the sustainability problem and change resistance and say that the system is trying to maintain an implicit goal. Here's what he wrote in his book. Peter's hidden balancing process is this loop. The loop is trying to maintain an implicit goal. The goal is right here. Until this goal is recognized, our change efforts, our solutions, are doomed to failure. That's an important insight with deep implications. Now let's return to the model. To summarize, the root cause of the source of change resistance is the corporate life form has the wrong goal, right here. This causes the system to have the wrong implicit goal. Fortunately, this has a practical solution. You change the wrong goal to be the right goal, so that the goal of corporations is the same as the goal of humans. This would be the long-term optimization of the common good. Once this happens, the system now has the right goal. The system will want, so to speak, to solve the sustainability problem just as much as it's not wanting to solve it now, because powerful root cause forces have been resolved. Let's move on to see how the WorldChange model works. We've taken the change-resistant subsystem shown here and added it to World 3. Here's what it looks like. We've made several changes to the World 3 model. None affect its basic behavior. One change is the scenario variable. This lets you instantly select the scenario to run. Let's see how this works by starting the model. Right now we're at scenario 9, and we can instantly select any scenario. Let's move it back to number 2. To us, this is the most famous and influential graph in the world. It approximates what will happen if business as usual continues. It's the problem to solve. For reference, let's bring in scenarios 2 and 9 from a talk Jorgen Randers gave last year at the 40th anniversary of the Limits to Growth. Notice how scenario 2 in World 3 here is identical to the one over here in the WorldChange model. In other words, we have made absolutely no changes to the fundamental behavior of World 3. We've made another change to the World 3 model by letting you select when the policy year starts. That's the year the World 3 solution parameters start. Let's turn that on. Nothing happens because right now it's set to 2101, which is way over here off the graph to the right. But when we take policy year, the start year of the solution, and move it to the left, collapse turns into partial collapse, almost no collapse at all, and then a much better world with lower population, higher resources, higher quality of life, that kind of thing. Now we're all the way back to 1940. This lets us see that one of the central messages of the limits to growth is so true. The earlier you start the solution, the better. Conversely, the later you start, the worse things are. Taking that all the way back to 2101. Now let's move it back to 2002, right here, and set this to 9. What we have here is scenario 9 from World 3 and limits to growth. This is what might have happened if the solution had started in 2002, but it didn't due to change resistance. To show how that will affect this scenario right here, which makes things look solved, let's turn the change resistance filter on, and instantly we can see what we've got here is not a solved problem, but partial collapse. We estimate change resistance to be high at about 80% right now. That means 80% of solutions are blocked, but about 20% get through. That's enough to change this to partial collapse instead of the full collapse we see over here. You can see how the change resistance variable works if we change it to a slider. Let's do that with a range of 0 to 1. Here, with 0 change resistance, we're now overriding the change resistance subsystem. The World 3 scenario right here is the same as solved, no change resistance. All solutions are getting through. But if we gradually move it from 0 change resistance to 100%, we're back to scenario 2 of World 3. In other words, the problem's totally unsolved, business as usual is happening. This tells us that the difference between these two scenarios, number 2 and 9 in World 3, is a matter of overcoming change resistance. Let's go ahead and end the slider option. I'm going to turn it off and get back to where we are. Now the change resistance subsystem is running again. It's too late to start the solution in 2002, so let's move it up to around today to 2015. If we started solving the change resistance problem in a global manner by resolving the problem's root causes, 2015 is about the earliest we could start. Let's put the model back to covering the full screen. Before we continue, let's remember that the World 3 model is not designed to make exact predictions. None of these future curves should be taken to be exact. This is more of a qualitative model, a qualitative prediction. It's good for determining the relative trends and the relative behavior of different solution strategies. Over here is the human welfare and ecological footprint graph from the World 3 model. We've added the change resistance variable to it, the thick red line. Right now, change resistance is high all across the simulation model because the change resistance part of the problem is unsolved. Right now, change resistance is high, so the system is resisting proposed solutions, causing this collapse. We're looking at scenario 5 of the WorldChange model, the pink column right here. We're not exactly solving the problem yet, because even this much collapse is horrific. So let's see if we can do better. Let's take a look at what happens if we start resolving the root causes of the change resistance part of the problem. Our analysis found two main root causes of change resistance. The first causes the success of change resistance. The second root cause, the deeper one, is the source of where that resistance is coming from. Let's resolve the first root cause with scenario 6. We change this from 15 to 16. It's not much of a change, but over here it's a big change, because what's happening is we're starting to solve the change resistance side of the problem. This falls from high to low. The problem is now solvable, but we're not quite done, because there's a deeper root cause, the source of change resistance. That's the root cause that matters. So let's solve that with scenario 7. Change this from 16 to 17. That's even better. The collapse is even less, but more importantly, look at the way change resistance has fallen from low to 0. Better yet, it's falling fast. This is a slow fall. This is a very fast fall, because we're resolving the deeper root cause. The implicit goal of the system is now the right goal. The goal is no longer the goal of corporatus profitus, which is the short-term maximization of profits. Now the goal of the system is the goal of Homo sapiens, to optimize long-term quality of life for those living and their descendants. The system will now seek to solve any and all problems that would optimize long-term quality of life. In other words, common good problems. At the top of the list of those problems would certainly be the sustainability problem. Let's take a look at the bigger picture, though. Long term, we've still got a problem. If we look over here at the state of the world graph, at this line, non-renewable resources, we see that it's falling and falling and falling. And right here at the end, 2100, it's still falling. Although it would appear we're starting to solve the population collapse problem and the food shortage problem, the red line, we haven't solved, well, the most important curve on the graph, non-renewable resources. This can fall, but it can never rise. That's why long term, it's the most important curve there is, and the toughest part of this problem to solve. So is there a better solution? Well, yes, there is. We've got quite a bit of good news here. Now that the root causes of change resistance are resolved, the human system has tipped into a new mode. It wants, so to speak, to solve the sustainability problem as fast as it can, because the system is following a new implicit goal. That means that solutions that could not be considered before are now on the table. They can be realistically implemented. In the World 3 model, the solution included a desired completed family size of 2, right over here. Now that the entire system is trying to solve the problem, this can be realistically changed to a one-child per family policy, just like China did starting in 1979. In the areas where that policy was fully implemented, the results were 1.3 children per woman. So let's use that. We're going to change this from 2 to 1.3. And that's pretty good. We have, instead of population collapse, a controlled decline. But we didn't really change the black line, non-renewable sources, at all. So we've got to go a little further. Now that the system wants to solve the problem, we can try another solution that could not be considered before. In the World 3 model, the solution included an average life of industrial capital of 18 years. Suppose we reduce that to 10 years. Let's first turn this on, and now start reducing it. And watch the black line, non-renewable resources, get better and better and better until we finally reached 10 years. It's moved from about here to here. More importantly, it's flattening out. It's reaching an invisible asymptote somewhere out here that's well above approximately 25% of non-renewable resources remaining. This is extremely good news. There's going to be plenty of resources for a lower population. What we're doing here in this rather radical solution is throwing away industrial capital like machines and tools long before it's worn out by reducing this from 18 to 10 years. That's a pretty counterintuitive solution, one we didn't expect at all when we started. The solution makes no sense at all. It's unprofitable. It's as inefficient and wasteful as you could imagine. But it throttles production down so much that long-term sustainability becomes possible. It thus appears that the sustainability problem can be solved. It all depends on overcoming change resistance and changing the goal of the system to where the global human system has the right goal and wants to be sustainable. The old goal was short-term maximization of profits. The new goal, the right goal, is the long-term optimization of quality of life. Let's summarize what we've done here by moving to the next page. These are the key WorldChange model scenarios. The first one, Scenario 1, is the same as World 3's business as usual scenario. It's the problem to solve. If we start the solution policies used in World 3 in 2015, we get Scenario 4. That's the earliest a global solution resolving the root causes could start. The solution is acceptable. There's no population collapse. But it's unrealistic because it's not what's happening. High change resistance all over the world is blocking most solutions. Change resistance is high, as this flat red line shows. So when we turn on the change resistance subsystem, we get Scenario 5, partial collapse. This is the real problem to solve. Global collapse is dead ahead unless we can solve the change resistance part of the problem. This can be done with root cause analysis. Our analysis found two main root causes of change resistance. In Scenario 6, the root cause of why change resistance is successful is resolved. That helps some, but it's not enough. Scenario 7 goes a little deeper and resolves the root cause of the source of change resistance. That helps even more. Now change resistance doesn't fall slowly. It falls rapidly, and it falls all the way to zero. Scenario 7 is hugely important. Now the human system has the right goal. It wants to solve all problems whose solution would benefit the common good. Democracy is now working like it's supposed to. This makes solutions that were impossible to consider before now feasible. One example is Scenario 8. This is a global one-child per family policy. Population now enters a managed decline. But this is not enough. The most important curve on the state of the world graph is non-renewable resources, the black line. It can fall, but it can never rise. In Scenario 8, it's still falling. Scenario 9 fixes that, as we can see right here, because the black line starts to level out well before 2100. That's pretty good news. That's due to a counterintuitive solution that seems just terribly inefficient. We've reduced the life of industrial capital from 18 to 10 years. We're throwing away capital. It's a solution we couldn't consider before because it was unprofitable. But now we can consider such solutions because the system has the right goal. Reducing the average life of industrial capital chokes down production, which causes non-renewable resource depletion to slow down so much that it flattens out at well above zero, somewhere above 25% or more. The result is we have an acceptable long-term solution to the sustainability problem. Our final conclusion is that once the root causes of change resistance are resolved, the sustainability problem is rapidly solvable. The problem becomes solvable once change resistance falls to 0 in scenario 7. Once that happens, the system now desperately wants to solve problems like climate change because large corporations all over the world want to solve the sustainability problem. Corporations are the world's dominant life form. Now that they're working for the common good instead of against it, solutions that were impossible before are now feasible, like one child per family in scenario 8, or putting the brakes on industrial production in scenario 9. More feasible solutions, not shown, would be pumping massive amounts of CO2 out of the air or perfecting a global 100% renewable energy system in just a matter of decades. Industry has already solved much more difficult problems because it wanted to. It had the right incentive. Likewise, once the world's corporations want to solve the sustainability problem, they will probably solve it as fast as we put a man on the moon. That's a bold claim, but consider how differently the global human system will behave once the root causes of systemic change resistance are resolved. One final observation. In the WorldChange model, solutions are implemented only as fast as change resistance falls from high to low. That's realistic. Now, it takes much longer for solutions to have effect this way, but it gives us model behavior that's much closer to how the real world behaves. This completes the introduction to the WorldChange model. Thank you very much.